Hi, welcome to this video, and we are on ninth video in the series of Mastering CISSP towards your cryptography. So we need to have a look at the algorithms, but before we get on to the algorithms, okay, we need to discuss about what is called as a stream cipher and the block cipher. If you remember the way we actually did it, okay, so we discussed about what is called a substitution cipher, and we also discussed about what is called as an transposition cipher. So transpose of a matrix and substitution is what we discussed. In a way, substitution is very similar to what is called as a stream cipher. In the substitution cipher, every character is replaced by something else. Okay, we had a key of +3, and we worked on attack at the dawn, and we substituted A with the D, T with the W. If you remember that, there's a substitution cipher. Stream cipher works in a very similar fashion. Before we get on to with the stream cipher, we change or we encrypt 1 byte or 256 bytes is a different story. So we have a different stream cipher. The most popular of all the stream ciphers is RC4. Okay, so R stands for the RON drivers, the R of the RSA. Okay, and most of the other algorithms that are very popular, okay, inclusive of data encryption standard, advanced encryption standard, blowfish, twofish, etc. There are block ciphers. Predominantly, most of the block ciphers works on 64-bit block with an popularity exception of AES, okay, which works on 128-bit block. Okay, so when I said attack at the dawn, so with the substitution cipher, the key of +3, A became D, and T became W, this became A again, okay, and C becomes D, E, F, and K becomes M and O, okay. So D, W, W, it's not a D, it's not a A, it's a D, okay. So this is what our substitution cipher is. Now for the transpose of a matrix, okay, we said attack at D dawn. The key is +4, ATTA, CKAT, THED, AWN, and Z as a filler. So we said this word is going to be the transpose of a matrix, okay, transposition. So we pick up the first column, which is ACTA, and we pick up the next one, TK, HW, etc., and we send it to the destination, okay? Now, if you carefully look at this particular transposition, every character is represented by 16 bits. So ATTA is 16 multiplied by 4 is equal to 64 bits. So if you look at the data encryption standard, we are going to have a look at the data encryption standard in a few minutes today in this particular video. So ATTA becomes 64. So data encryption standard works on 64-bit. Okay, so 64 plus 64 plus 64 plus 64. Okay, so ATTA becomes one block, and CKAT becomes another block, THED becomes another block, and AWNZ becomes another block in the block, okay? So let's not confuse between should we pick up ATTA or ACTA, because, you know, I'm just trying to prove to you or make you understand that every block has 64 bits in case of a data encryption standard. Yeah. So coming on to the algorithms, okay. So the National Security Agency, as a part of National Institute of Standards and Technology, so they actually want to have an, a standard algorithm to be used in the United States. So they invited paper from a lot of organizations, and many presented their algorithm, and IBM also presented their algorithm. And this algorithm is actually called Lucifer. Okay, so Lucifer was an 128-bit algorithm. Okay, 128-bit algorithm. The National Security Agency actually got this particular algorithm, and they lessened the the encryption crypto variable bit from 128 to 64. Okay, out of 64, 56 is actually used for the encryption, and the remaining 8 is actually used for the parity. Now that was in requirement of the RFC at that particular point of time, that we need to have a parity bit for the cryptographic key or crypto variable or encryption key, whatever it is. Okay, so whenever there is going to be a modification or a loss on this 56-bit key, then we can actually build up from the 8-bit parity. So parity is something from which you can actually build the data that is lost or that is modified, that becomes a veritable base of your RAID 5 and etc. Okay, RAID concept. Okay, in fact, the bit splitting as a part of the cloud is also based on the very similar concept. So 56 plus 8 is actually used for the data encryption standard as a key, out of which 56 is the encryption key and 8 is actually used for the parity. So 2 to the power of 56 is actually the key space that you're going to have for the data encryption standard. So data encryption standard, the block size 64 bits. Okay, 64-bit block. So for attack at the dawn, okay, so attack at the dawn, I have conveniently did not take the spaces for the illustration purpose, but actually when you do an encryption, the space is also considered as a part of your calculation. So ATTA becomes a 64-bit block, CKAT becomes a 64-bit block, and THET becomes a 64-bit block, and AWN, Z is a filler, also becomes a 64-bit block. Okay, and all these 4 blocks may work in a parallel or maybe chained together, okay, depending upon what you call as modes of the data encryption standard. There are 5 modes for the data encryption standard. They are electronic code block, cipher feedback mode, output feedback mode, and cipher block chaining, and then what is called the counter mode. In fact, the cipher block chaining is actually the second mode that is presented in the textbooks. Okay, so it's electronic code book, and then cipher block chaining, cipher feedback mode, output feedback mode, and the counter mode. Counter mode and the electronic code book works in parallel. That means there is no chaining between one block and another block. But in cipher block chaining, cipher feedback mode, and the output feedback mode, there is a chaining between one block and another block. Okay, there is the initialization vector that is added to the first block, and the remaining block will have a copy from the previous block. So depending upon the copy from where it is actually taken, the name actually differs between one mode and another mode. Okay, now we saw 56 plus 8 is 64-bit, and 64-bit is actually a key, 64-bit block. So block size is also 64-bit. And each and every block undergoes what is called a 16 rounds of confusion and diffusion. Confusion, diffusion, very similar to the substitution and transposition. In fact, if you do a substitution and transposition using different keys, that is actually called as a super encryption. And it does a super encryption for 16 rounds of confusion, diffusion. Now, the 16 rounds of confusion, diffusion, which the data encryption standard undergoes, is not with the same key. Okay, there is actually a catch in this. Okay, so let me remove this M from here. Okay, make it a block. Yeah, there's actually a catch in this. And this is what we are going to actually see for today, and remaining things on the next video for you. Thank you. Bye-bye.